So I'm recording. We'll put that up there. And please make sure it's first name, last name, dash, followed by the word here in uppercase. I've been seeing some different versions of this. I've seen some colons and some spaces without a dash at all, and so on and so forth. So first name, last name, dash, uppercase here, if you want to get credit for attendance. Awesome. Thank you. All right, let's talk about Bash. So we've discussed Linux, right? And what Linux is, and Linux is, you know, it's an operating system, etc., etc. And we're gonna use the word Bash a lot. We're gonna talk a lot about Bash, and Bash is actually a little different from Linux. So I've just logged into the Linux server here, and you know, I can say show me my current directory and list the files in here, and show me how much disk space, and tell me what the date is, and so on and so forth. Those things that I'm typing, date, ls, pwd, are not technically part of Linux. They're actually part of what we would call a shell. And a shell is really just a program whose purpose is to wait for me to type a command, and then based on what I typed, take some action and maybe show me some output. Okay, that's what a shell does. And there's a number of different shells available. So one of the first shells that people used was something called the Bourne shell, B-O-U-R-N-E, and it was just SH. And you know, you would log into a Unix machine, and the operating system is, you know, sitting there doing its thing, but there's a program named SH, the Bourne shell, that was running, and that was the thing that printed a prompt, like a $sign, right, or a greater than sign, and would wait for you to type something, and you type DATE, enter, and because of what this program is doing, suddenly your display would show you the date, and then it would come back and show you another prompt, a $sign or whatever. So that was the Bourne shell. There's the C shell, which has, you know, a different feel to it, but it looks more like what you would do in a C programming environment. There's the Corn shell, KSH, and then someone came up with the Born Again shell, so that's a play on the word born from the Bourne shell, SH, and we just call this Bash. And this is the shell that we're using in this course, and this is probably the most common shell right now. This changes over time, like programming language, but Bash has been a popular shell for a long time, and it's just a C program. It's a C program that's running as soon as I log into the Linux server. An instance of Bash starts running, and it's literally running right now. And this stuff that I'm typing is input to this C program. So there's something, you know, using an fgets call probably to read from standard in, and it will, you know, decide what I meant from this, and then that C program will use a print statement that ultimately prints out, you know, dash bash colon blah 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 colon command not found. But it's just a program. Everything in Unix is really just a program. So I can say bash, and this will start a new bash shell for me. And you can tell it's new because my prompt number, you know, went back to 4999. And if I exit from here, I come back to where I was before I said bash, and now I'm about to do command, you know, 5008 instead of 5007. And so if bash is a program, where is it? Well, we can say which bash, and it'll tell us /bin/bash. So if I look at /bin/bash, let me do an ls-l to see some details. Right? It's just a file, but it happens to be an executable file. And you know, I could copy that file. I'll make a copy of it called my file. And now, you know, I'm sitting in my CSE224 directory, but I have a file in here called my file. And if I were to execute that, guess what? It runs a bash shell. And, you know, I'm back to the beginning of my bash history and so on and so forth. And, you know, I'm in my home directory. Oh, I'm not in my home directory. But if I exit from here, I go back to where I was. And I could, you know, try to VI that file, but it's not meant to be human readable, other than the word elf that always appears in the beginning. But it's basically binary code. A lot of what's in here is machine code that is understood by an x86 CPU, an Intel processor, or an AMD processor. And the culmination of this machine code is to do these things that we've been describing, to print a prompt, wait for input, and then respond to the input. And it's pretty big, but not huge, right? It's 1.3 megabytes. Well, is that a lot? No, if you download a game from Steam, you know, it might be 2 gigabytes of download, so it's not big compared to that. But 1,000,000 bytes of machine code is actually a lot. You can do an awful lot in there. A lot of programs will write might take, you know, a few hundred bytes of machine code. So this is you know, an executable program, and it's got all this stuff in here. And if you like, you know, you can make changes to this. Now, if I just change something at random, like, you know, let's just insert some stuff over here. Will this still work? I don't know. Gives me a seg fault. But there might be other things I could change where this would still continue to work. Alright, so bash is one of multiple shells that we can run. We're always going to use bash in this course. And a shell is really just something that reads commands from a user and then takes some action. And what we want to talk about today are some starting commands we can use in bash. So we've done some of these before, right? There's a command date, which shows us the current date. There's pwd, which tells us what directory we're sitting in. There's a command called cowsay. If I say cowsay hello, it will show a picture of a cow saying hello. Arguably the most useful command in all of Linux. So there's all these different commands that we can type. Sometimes what we find is useful is if we have a series of commands that we run over and over and over again, we'd like a shortcut so that we don't have to type in these commands every time. We could just have you know, something that does a bunch of commands for us. So this is what a shell script is. So a script is like, you know, a movie script. It lists the things that should be done in a particular order. This person moves here, and then they say that, and this other person does such and such. A bash script is a series of instructions that tell bash what it should do in a particular order. So let's write a simple bash script, and I'll just call this code 1. And I'm going to say echo. I'm going to say date. Let's see what the date is. And then I'm going to say, let's see what directory we're in. And then I'm going to have a cow say to me, hello, Nick. Alright, now if I type these 3 commands into bash, I'll see the date, I'll see my current directory, and I'll get a cow talking to me. Let's see, running bash restarts the program counter because there's so many commands bash runs to operate. I have my history set up in bash to record 5,000 commands. So it always starts with showing me that I'm about to enter command 4,999. And it's basically forgotten about anything, you know, 5,000 commands or older. So it just resets that counter for me. But if I set my history to be 100, then it would start with 100 or 99. Alright, so I've got three instructions in this file called code 1. Now, ideally, if I say code 1, it will go ahead and execute those 3 instructions. But by default, you cannot execute files like this. Okay, so there's this notion of permissions. And here's the thing, right? If I just say code 1, what it should do is take each of the lines in this file and execute them as bash commands. But suppose that code 1 is actually something different. Suppose it's, you know, an email message that someone sent me, and it's got 500 lines of communications from a friend. If I were to execute each of those lines as a bash command, who knows what would happen, right? It would probably do weird things to my directory. It might delete files and so on and so forth. So by default, when you create a file, you're not allowed to execute it. And you can see that you're not allowed to execute it by doing an ls command with a -l switch. So if I say ls-l, this file code1 has a series of letters and dashes over here. These are called the permission bits. And permission bits work like this. There's 9 symbols. And they could be RWX, RWX, RWX. And any or all of these could be dashes instead of the corresponding letter. Okay, these show what different people are allowed to do with this file. This first set of letters says what the owner of the file is allowed to do. The second says what people who are in your group are allowed to do. And the third says what everybody else in the world is allowed to do with this file. And this first letter, R, means read, which means you can, you know, look at the contents of the file. The second letter says write, which means you can make changes to the contents of the file. And the third one that we care about right now says execute, which means I can run this by typing the name of the file, and it'll execute it as a bash script or as a binary file or something. So when I looked at my file code1, it told me it's owned by Nick, that's me, and the group that I belong to is faculty. So I think I created an account for Izad a number of years ago. He's in the group faculty also. So the permissions on this file are the owner, me. I can read, I can write, but I'm not allowed to execute. And other people who are not me but are faculty are not allowed to do anything with the file, and the rest of the world is not allowed to do anything with the file.
For read, write, execute, in order to execute, do you also have to be able to read?
It's a good question. Let's find out in a minute. I think you do, but we'll try that. So I have really restrictive permissions by default because, you know, I make sample versions of assignments and so on and so forth. I don't want my files to be executable. But by default, if you do this on your system, I think what you'll see is something like this: RW dash R dash dash R dash dash. So this says I'm allowed to read and write but not execute. Other people in my group, for you that would be students, are allowed to read but not modify or execute, and other people in the world are allowed to read but not modify or execute. And so if I try to say code1, it's going to say permission denied. So if I want to change those permissions, the way to do it is the chmod command, chmod. And here's how chmod works. Figure out what the 9 permission bits are that you want. Owner, group, world, read, write, execute. If you want to grant that permission, put a 1. If you want to deny that permission, put a 0. So I want to be able to read, write, and execute. I want people in my group to be able to read, not write, but execute. And I want people in the world to be able to read, not write, but execute. All right, I've got 9 bits. Break them into groups of 3. Think of it as an octal number. This is the number 7, 5, 5 if I treat each of these as binary. So to make these permissions, read, write, execute, read, execute, read, execute, I'm going to use the chmod command, and I'm going to give it an argument of 755. And then I'm going to tell it what file I'm trying to change the permissions on, code1. So I'm going to say chmod, and that's what I snuck by up here. I'm going to say chmod 755 code1. And now if I do an ls-l, you can see I've got read, write, execute. Everybody else has read, execute. Members of my group, members of the world. And I accidentally did the punchline. If I say code1, it'll go ahead and execute the contents of that script. So it shows me the date, It shows me my directory, and then my cow says, hello, Nick. All right, so that's our first shell script. And it's really just a series of commands. But this could be useful, for example, when you're using git. You know that after you've made some changes to your file, what do you want to do? Git add star, git commit -m some message, git push origin master. Well, I could put those 3 commands into a script. And now every time that I type the name of that script, it executes those 3 steps. Maybe I want to make a copy into a backup directory. I want to copy, you know, file1.c into a directory called backup. I could add that to my script also. So one use of scripts is just to take a series of commands that we're going to execute a lot and bundle them into what would be called a batch file in DOS, right? So a way to preserve a bunch of commands. And somebody pointed out in chat, you can also say chmod +x, and that adds the execute permission to a file. But make sure you understand the mapping from permission bits to this octal code and being able to do this command, because that always pops up on tests. It's an easy question to ask. All right, next thing we want to talk about is something called a shebang. So when I type code 1, it executes these commands, but what executes these commands? What is it that's executing the command date pwd cowsay? Well, right now I'm running bash, right? I can say ps to say show me all the processes I have running right now. There's a process called bash. That's my shell that was created when I first logged in. Since I'm running bash, if I say code 1, these commands will get executed by bash. But if I happen to be running something different, if I happen to be running the corn shell or the C shell, then when I said code 1, these commands would be executed by the corn shell or the C shell. And the programs we're going to write are going to be intended for bash. And if somebody who's running a different shell tries to execute our script, it may not work. So if we want to make sure that when somebody says code 1, these commands get run by bash, we're going to add one extra line in the beginning of our script. And this is called a shebang, and it's a $! followed by the full description of the program we want to have executed. In this case, it's a program called bash sitting in a directory /bin. And even if we don't understand exactly what this means, just always, 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 when you write a bash script, make this the first line. And it has to be the very first line. If I put an empty line in the beginning of it, this is not a shebang, it's just a comment. And anything that begins with a number sign, or anywhere that there's a number sign in your script, that's taken as a comment, it's completely ignored. If I put this in my second line of my file, it's completely ignored. But if it happens to be the very first line, and it's exactly $! /bin/bash, it's treated differently. And the system will say, okay, I'm going to run this through the bash script, the bash shell, and it's going to execute each of these commands. All right, so always put that in the beginning of your scripts. All right, well, writing scripts that always do the same thing can be fun for a little while, but eventually, you know, since we're programmers and we want to do things that execute algorithms, we need more of the constructs that we're used to dealing with in C or Python or whatever programming languages we like. So one of the first things we need is variables, right? We got to have a way to be able to take information and store it somewhere and then get back to it later. And so variables in bash, right, are very much like variables in C. They can be pretty much anything as long as they don't start with something like a number, right? So we could have x12, well, we can't have 12x. They're case sensitive, uppercase x, lowercase x, different variables. We can have underscores inside them. We can't have too many funny characters, though. We can't put, you know, a question mark inside the name of a variable. But if we stick to, you know, sort of reasonable variable names like x, for example, we're pretty safe. So I can say x equals 10. Well, I've just set up a variable named x and given it a value of 10. Now, you don't have to declare variables. I didn't have to say integer x first. So bash is what we would call loosely typed. It will figure out what kind of thing x is, and it will act accordingly. Sort of. All right. So one of the useful commands in bash is echo. And echo is just like, walking into a large auditorium and you shout and you hear whatever you shouted come back at you. That's what the echo command does. So if I say echo hello, it says hello. That's all it does. If I say echo blah blah, it says blah blah. All right, so that may not seem terribly useful, but it's actually like the print function, basically. It lets us produce output when we want. So I could take my code one script and I could modify it, and I could say echo, and I'm going to use double quotes when I want to echo things. Echo will actually let you get away without using double quotes. But in general, when we want to use strings of characters, we're going to put them inside double quotes. So I'm going to say echo the date is, and I'm going to show the date. And I'm going to say echo your directory is, and then I'm going to show what the current directory is. So if I say code 1, now it's a little more interactive. It says the date is Tuesday, September 23rd. Your directory is HomeNIC CSE224. Well, I set X.
The PWD command, does that have to be on a separate line, or can you put it after the double quotes to get it all in one line?
Right now it's got to be on a separate line. I could put it on the same line with a semicolon, but it would still print on a separate line.
Okay.
But there's ways I can change echo to not automatically put a new line at the end.
It'd just be like formatting in C, right, basically?
Yeah, so I think if I say echo -n, that'll tell it to not print out a new line at the end. So now it says the date is Thursday. But it also doesn't print a space, so let me put a space here in the beginning, and let me change this to echo -n. Your directory is. And so now it says the date is, your directory is. So that looks a lot nicer, right?
Yeah, that's cool.
And if I didn't know how to do that, I could say, show me the manual pages on this echo command. And one of the first things you see is there's a switch, an option I can put in -n, do not output trailing new line. So that's all we're doing is using a switch to modify the behavior of the echo command. Switches are just things that usually start with a dash, like when you say ls-a, I'm saying, hey, I want to modify what ls does. When we say echo -n, we're saying I want to modify what echo does. So that can be useful.
Pretty much all commands have that, where you just pull command pages and see.
Yeah, most commands, so like GCC is a good one to pick on, right? It has a bunch of switches you can use. There's a few of them mentioned up here, but all of these switches work, and so on and so forth. And so most commands you can put a dash and one or more letters or numbers to modify what they do, and the manual pages will tell you about it. And this is another case where, mostly we'll learn maybe one or two. We'll learn ls-a, ls-l, and that's pretty much it. But there's a lot of other modifiers you can put on ls to do, you can do almost all and author and so on and so forth.
Would you say in the field we use those quite a bit, or there's very few that you're going to use?
I don't think I've ever used anything except -l, -a, and -rt. And RT I only started using like 2 years ago. And that shows me reverse chronological order listing. But
So they're kind of cool and could help at times, but most of the time you're not really going to use most of them.
well, I'm not, but you might, right? You won't see me use them in class, but you may end up needing to do something again and again and again, and you know, at some point, maybe you like looking at files in reverse alphabetical order, right? And so there's a switch you can put on ls that'll say, show me reverse alphabetical order. And that may be something that's really useful to you. And that may end up being one of the things that you use all the time with ls. It's going to be different for every person. And so this is where I keep coming back to, you know, inviting people to explore, and definitely don't get bogged down. Don't try to learn everything that you can do with ls, because, you know, you can buy a whole book on ls. But you know, if you find that there's something that keeps bumping, you know, you keep bumping up against, take a look in the manual pages, see if there's a way to do something more easily or more naturally for you, and you'll end up building up your own kind of tool set.
Okay, thanks.
Yeah, you're welcome. And yeah, when we get to grep, there's a bunch of good switches in there too. I tend to be pretty lazy, and so I learn like just enough to do what I need to do. And you can put commands together in Unix in really powerful ways. And so if I want to sort, you know, something, I'll just pipe it into sort, even though there's usually an option on most commands to sort the output and so on. All right, so way up here I said x equals 10. And I claim that set a variable named x to have a value of 10. Well, we should be able to see that, right? So let's echo x. And what do you think it's going to show me? It's going to show me x, right? It's really just a giant echo chamber. So if I say echo x, it says x. If I say echo x plus 1, it's going to say x plus 1. So if you have a variable and you want the value of that variable, you use a $sign. So if, for example, I say echo $x, hey, now I'm seeing a 10. That's the value that I gave my variable up here. And if I say x equals 22 and I echo $x, shows me 22. So x is just an x. $x is the value of a variable named x. So if I say echo $x plus 1, what's it going to give me? 22 plus 1. All right. Echo is very sort of straightforward and simple-minded in its behavior. And what I literally told echo was echo, and instead of $x, it saw the number 22. Bash actually replaced that $x with a 2 followed by a 2, and echo actually saw echo space 22 plus sign 1. And so that's what it echoed. Right, so keep this in mind. Echo is very mechanical.
So it's not going to do the arithmetic for you, it's just going to add it on, it's just going to display it as that.
Yep, it's just going to take back whatever, it's going to give back whatever I gave it. But Bash I can actually coerce into doing arithmetic for me. So if I want to actually do an arithmetic expression, I use this very peculiar syntax. I'm going to say $, parentheses, parentheses, and then some expression, and then 2 closing parentheses.
And now is that just like a bash script? It's just doing a command that somebody has written at some point?
More or less. It's a little higher level than a script. It's actually something that Bash itself understands, I believe. It might be calling a script called expr, but I think it's actually managed by Bash itself.
Okay.
And there are a lot of ways you can do arithmetic in Bash. This is the only way that you can do it that you'll get credit for in this course, though. So Bash is one of the few places where I'm going to be really, really dogmatic in how we do things. And the reason is there are a lot of ways to do things in Bash, and most of them are not correct, but may work anyway. And so if I ask you on an exam to, show me a bash statement to do such and such, you might type something that will end up working once in a while, but not always, right? And I don't know if you were really, really, really smart and knew that in this particular instance, this different version of a command would work correctly, or if you just got lucky, right? So I'm going to insist that when we do arithmetic, we use it with $, parens, and we put our expression inside. So how does this work in practice? Echo 1 plus 1, it says 1 plus 1. Echo $, 1 plus 1, it says 2. All right, that's the whole heart of the matter right there. If I were to just say 1 plus 1, it'll say 1 plus 1. If I say $, 1 plus 1, it'll actually calculate 1 plus 1. Or 1 plus 11. And if I do 12 times 2, it does 24. Someone said, what happens when you do only one set of parentheses? It says, command not found. Now there are cases where we'll do things with 2 sets of brackets, for example, and 1 set of brackets may work, may not. But even when it works, it may not be working for the reason you think it is. But you can always experiment and try, right? Just make sure for assignments and for exams that you always know how to do it the way that we're talking about in class. And like I say, it's really one of the few cases where I'm going to be dogmatic. Most of my courses, I basically say find a way that makes sense to you. And with C, almost all the time, I say find a way that makes sense to you, right? But Bash, I'm going to be really, really particular about it. All right, so what was x equal to? X was equal to 22. If I say echo $, x plus 1, it says 23. So I can do arithmetic now, right? This is helpful. All right, let me suggest double quotes. When we do our echo statements, we're usually going to want to put things inside double quotes. And so far, if we don't do that, it hasn't caused any problems. But there will be cases where that will cause problems. For example, if I want to say, right up here, I wanted a space to appear at the end of my output. Right? If I didn't have this in double quotes, I wouldn't get the space. And there's special symbols sometimes, like asterisks. If I say echo asterisk, it tells me code 1. What the heck does that mean, right? If I wanted to show me an asterisk, I have to put it inside double quotes. So best habit, always put your things inside double quotes.
Did you say that's more like a fail-safe, so that you always get what you're looking for?
Yeah, exactly.
Okay.
But remember, with double quotes, $ still get interpreted as, show me the value of a variable or do some arithmetic. If you don't want that to happen, if you really want it to show you literally what you've typed, you can use single quotes. And a single quote just says more or less, show me exactly what's inside the single quotes. So that's how we can print out things like $. So if we're doing our Mr. Krabs impersonation, say make lots of money, it comes out make lots of, right? Because Bash said, oh, they must want the value of this variable money, and it didn't have a value, so it didn't print anything. So if we wanted to print this literally, right, that's where we can use single quotes. And now we get our mantra. All right, and there's lots of stuff that we can do in Bash with single quotes, double quotes, and back quotes. We'll play around with all of these more. But for ODP 402 and for Programming assignment 1, I think for the most part, maybe for all of it, we can just do double quotes. All right, so we can make our script a little more interesting. So I'm going to say my name is equal to Nick, and I'm going to say hi name, the date is this, your directory is this, and then for cause, I'm going to say cause hello, and instead of Nick, I'm going to say name. So if I say code 1, it says hi Nick, the date is, your directory is, and then the cow says hello Nick. All right. If I change this and said my name is, you know, I'm going to be the Queen of England. So my name is Elizabeth. It says hi Elizabeth, the date is, your directory is, and then the cow says hello Elizabeth. So we can use these variables like this. But, you know, if I want to change the value of this variable, I have to edit my script, and that's kind of a drag. So a lot of times what we want to do with programs is we want to let the user specify some information, some input to the program, and then have the program act on that. So this is where we're going to use a command called read. And read basically says stop what you're doing, wait for the user to type something in, and then whatever they typed in, assign that to some variable. Oops. All right, so for example, if I say read X, Bash will sit here. It's not showing anything. It's waiting for me to type. I can say ha ha ha. And now if I look at the value of X, it's equal to ha ha ha. If I say read X and I type 135, now I look at the value of X, it's 135. So read is a useful way to get input from a user. So I could change this and I could say echo who are you, and I could say read name. And let me just go straight to the cow say. So this will say who are you, it will read input from the user, it will save that input in this variable called name, and then my cow will say hello name. So if I say code 1, it says who are you, I'm Nick, it says hello Nick. If it says who are you and I say, you know, I am Dr. Nick, it'll say hello Dr. Nick.
So the variables, are they only declared inside your script? So like you can't make name Nick and then, you know, try to do another script and have it also have the same variable.
So if I look for name right now, it doesn't exist, right? Okay. So when you run your script, it's actually running in a separate bash shell. The other thing is, in general, if I create variables here in my interactive shell, and then I run a script, those variables don't exist inside the script. It's a totally separate instance. We can get around that later using a command called export. But we'll talk about that another day. So let me change this a little bit. Let me say how old are you, and I'll read my age, and I'll have my cow say next year you will be, and I wanted to show my age plus 1, so I'm going to say $paren age plus 1. Everybody see what we're trying to do here?
So does it create an error if you put a non-numerical answer for age? Like you just put, you know, hello?
Oh, let's find out. And let's also find out that permission question from earlier. So code 1, how old are you? Let's say I am 29. So it says, next year you will be 30. Right? And that's all you need to do ODP 402. And that's a bulk of what you need to do PA1. Now if I do a non-numeric age, and I say my age is ha-ha, it'll usually treat that as a 0. And so it'll say next year you will be 1. And let me go back to a question from earlier that I forgot. Do you need read permission to be able to execute? So let's change our file to be, let's just make it 400. So let's make it 100. So I've got execute permission, but I do not have read permission. I don't think it will let me execute it. And it also won't let me remove it unless I say override the permissions. And if I try to VI it, it'll say permission denied because I don't have read access. But since I own the file, I can change the permissions and then make it executable again. All right. Yeah.
How can we tell if we're in the bash shell or not?
Say again?
Is there a way for us to tell if we're in the bash shell at any given time or not in the bash shell?
It's an interesting question. So I mean, you're always in a bash shell. If you echo $0, that's a special variable which will in some cases tell you that you're inside a bash shell. But we'll talk about that. We'll talk about that a lot more later. But let's just see what $0 is when I'm running this script. So it says $0 is /code1. So $0 is kind of like the thing that you're sitting in right now. If it's a shell script, it'll show you the name of the script. If you're just sitting at your bash command prompt, it'll show you -bash. But there's a lot more we have to say about that eventually. Alright, so let's take a look at ODP 402. So as Canvas says, the actual assignment prompt is on the Linux server under /tmp/readme-402, and this is generally where these will be going forward. And your assignment is to write a bash script that basically reads one line of input from the user, multiplies it by 2, prints the number out. And that's all it should do. Okay, and then to assess it, remember the assess command needs 2 arguments. It needs the name of the program that should be run, and it needs the name of the source code. Well, in this case, you know, we don't compile bash scripts, so we're going to say ODP 402 and then ODP 402 again. So let me show you what this looks like. So I've just written my ODP 402, and if I run my assignment, it does not type anything. If it types anything, it's not going to get you 10 out of 10. Okay, so when I run my program, it should just sit there and wait for me to type in a number, and when I hit enter, it should just print out twice that number and then exit. And if I type a negative number, it should still print twice that number and exit. And I'm not going to test this by typing something that's not a number, so you don't have to worry about, you know, what if the person types a letter or something. But if you type a positive number, negative number, or 0, it should just print out twice that number and exit. And it's got to do exactly that, nothing more, nothing less. If I were to print a prompt in the beginning saying enter a number, I'll get 0 out of 10. If I print the answer is and print twice the number, it'll be 0 out of 10. So you got to be really, really strict in interpreting what the program is supposed to do. Alright, so let me assess this. Assess ODP 402, that's the executable. ODP 402 is the source code. It's kind of silly to type it twice, but you got to do that. That's just how I set it up. So it'll say go ahead and assess your code for ODP 402. If this says 401 or 403, make sure that's the assignment that you're about to do. If this says 403, it means that you missed the deadline for 402. You got to do ODP 403. Okay, I'm doing 402. I'm going to go ahead and say grade. It runs 3 different tests. I got 10 out of 10 on each. I'm good to go. That's 100%. So this will get recorded internally as 30 out of 30, and then on the weekend when I push the grades to Canvas, it would show up as 100%. If I didn't handle negative numbers very well, then I might only get 10 out of 10, 10 out of 10, and 0 out of 10. When that got pushed to Canvas, it would be a 67%. So make sure that you get 10 out of 10 on every test. And then just extra Control D. Will what be case sensitive? Generally everything is case sensitive. So the G command is case sensitive. The name of the ODP is up to you, but you know, if I called it uppercase ODP and I try to run lowercase ODP, I'll get all kinds of errors when I try to assess, and I get a 0 out of 10. And guess what? That just overwrote my 10 out of 10 that I got a moment ago. So if I left right now and said, oh well, right, my final grade would be 0. So make sure that you get your 10 out of 10. So there we go, we're all good. So for the ODPs, I'm not worried about plagiarism, unless, I mean, don't plagiarize, right? But I'm not going to look at 2 assignments and say, hey, these look the same, because, you know, there's only a few ways to write this. You know, if you do something if you were to copy code, right, and there was a 50-line version of this program, and I got the exact same 50 lines from 2 students, I would start to wonder. But, you know, if you write this yourself, totally on your own, there's a good chance it's going to look exactly like somebody else's. That's okay. So don't worry about that.
Should we be commenting in Bash scripts?
You don't have to. You can. And you know, in Bash, if you put a number sign, that becomes a comment. Everything after that's ignored. It's not a bad idea to get in the habit of commenting, but I won't grade you based on whether or not you commented your Bash script here. But for PA1, we're definitely going to want to put comments in, and that'll be part of your grading. All right, send me one more attendance ping. Let me know you're here. You should have enough to do ODP 402. If you get into trouble and you want help with email, you got to send me a really, really detailed email message. You can't just say my program doesn't work, right? Tell me exactly what command you're typing. Show me exactly what your script contains. Show me a screenshot or a capture of your entire session, how you ran the assess command, how you did the G command, what the output was. The more information you give me, the more I can help you. What I can't do is swap 20 emails back and forth trying to get more information from you. So tell me as much as you can about your situation. There's a better chance I'll be able to say, oh, you know, you spelled the name of your file wrong. Or, you know, you printed a prompt. Try taking that out and run it again, right? So work on 402. Let me know if you get into trouble. Otherwise, I will see you tomorrow. We'll dig more into Bash. We'll learn what we need for ODP 403, which is just one more thing. And we'll talk about PA1 tomorrow. All right, have a good one. Thanks. Catch you next time.
I have a question.
Yeah.
It's about programming assignment 1.
Let's talk about it in office hours because I have to get to another meeting right now.
Okay.
All right.